This is Mr. Beck Does Your Homework. This is AP Physics, homework 2.7, question number 10. It says a car is parked near a cliff overlooking the ocean on an incline that makes an angle of 35.5 degrees with the horizontal. The negligent driver leaves the car in neutral, and the emergency brakes are defective. The car rolls from rest down the incline and has a velocity of 5 meters per second when it reaches the edge of the cliff. The cliff is 27.9 meters above the ocean. How far is the car from the base of the cliff when the car hits the ocean? So what I'm looking for is this displacement. And since it says how far, I don't care about positive or negative in this instance. The acceleration of gravity is 9.8. So let's see. I've got x world. I've got y world. X world, my acceleration is 0. Y world, my acceleration is g is negative 9.8 meters per second squared. I know that my displacement in the x world is what I'm looking for. In the y world, I'm going to have a displacement of negative 27.9 meters. I'm going to displace down by 27.9 meters. My initial velocity in the x and y world, what I've got is I've got this velocity that's coming down this way, and it's going to have a y component and an x component. This y component is negative, so I'm going to worry about that being negative. In this case, since the car is going to the left, I could say x is negative as well, but I'm not going to worry about that because it's going to ask me a final. So I'm just going to define this as positive, but this is negative. So I'm going to leave this y component. When I find it, it's going to have to be negative. So I've got this triangle that is 5 meters per second this way. I'm looking for my y and my x. Now, if this is 35.5 degrees, what does that tell me about this angle? Actually, it turns out that this is my angle that's also 35.5 degrees, right? 35.5. So my initial velocity in the y world is going to be my v times the sine of theta, because it's opposite that angle. So that's going to be my 5 meters per second, right? 5 meters per second times the sine of 35.5. It's going to be my initial velocity in the y world. In the x world, my initial velocity and my final velocity and my all-time velocity is going to be my velocity times the cosine of the angle, because it's adjacent to that. So that's going to be my velocity of 5 times the cosine of 35.5. So that'll be my velocity in the x world. Now, if I could find time here, then I could find my displacement, because my displacement is going to be my velocity times my time. But where I'm going to find my time is in the y world. I have an acceleration, I have an initial velocity, I have a displacement. I'm looking for time. And now let's see what I get. If I use my equation that says my displacement is my initial velocity times time plus 1/2 my acceleration times time squared, my displacement has a value, my initial velocity has a value, my time is what I'm looking for, my acceleration has a value. This would be a quadratic. Now, we could go and solve the quadratic, but I'm not going to do that. I'm going to do it a different way. What I'm going to do is I'm going to look for my final velocity first, and then from my final velocity, I'm going to find my time. So my final velocity squared equals my initial velocity squared plus twice my acceleration times my displacement. So this one I can solve, where my final velocity squared is my initial velocity, which is this 5 sine 35.5. And by the way, that's negative. It won't matter here because I'm squaring it. So I'm going to get my initial velocity squared plus this one will be negative. Actually, that's negative and that's negative. So twice negative 9.8 times negative 27.9. Both of those together make that positive. So that's positive, that's positive. It'll all be even a bigger number. When I square root it, I get my velocity final. Okay. Now, how do I get my time? Now I can do my final velocity is my initial velocity plus my acceleration times time. That way I've avoided the quadratic. So my final velocity, which I got from over here, is my initial velocity, which I got from over here, plus my negative 9.8 times my time. So now I can get my time from here. So time equals, and I've got myself a number. Once you solve for time, now you can pull it up here. So now I've got my x equals my velocity, which is 5 cosine 35, will be my velocity, and my time is going to come from here, and that will give me my answer for my displacement. And that should be a positive number because it just says how far.